Hello friends, this is Professor Ghanshyam Rathod, and now in this video we are going to see negative series clippers. Negative series clipper. So I'm going to draw that circuit. Here I have directly written negative series clipper. There is no any written bias or unbiased. Basically it is unbiased one, and the diode we are going to use in this one is nothing but an ideal diode. In last videos we have already gone through positive series and positive shunt clippers. So in this one we are going to check negative series clippers. So in this circuit over here we will connect our components. So let me draw that diode over here. So this is negative series. Series means the diode is in series with the load resistance. So this one is our load resistance RL. This side we input signal, and over here we are going to observe our output signal. So let us see what is our input. I'm just going to draw that. In majority of our circuit we are taking uh, input as sinusoidal waveform. So this one is a time axis. These are the vertical. Vertical is nothing but amplitude, and in amplitude we are taking as in voltage. So here is V input, and this one is a time. So I'm drawing that signal. This is input signal, positive half and negative half. Then once again the signal is repeated. So just two cycle I have taken. This is positive and this is negative, starting from 0, positive half, negative half. This one is plus V max, and this one is minus V max. Now we'll check for the positive and negative half cycles. So first of all we'll apply positive half cycle. So positive over here, current will flow like this way, and negative will be here. So this terminal is P, or you can say anode. This is N, you can say cathode. So as we know the condition Vp minus Vn, that should be greater than 0 for ideal diode. Ideal diode, you can say diode will be in forward bias, or you can say that is on. So here P terminal or anode terminal cathode is positive, this one is negative. Now you see the diode is in forward bias, so you can say this diode is on condition. Now we'll see that circuit, that how the circuit will look alike if the diode is in forward bias, and we'll see that output in such case when diode is in forward bias. So here is we need to connect diode. So diode in forward bias, so we can say directly diode is in forward bias, so it is connected directly, short circuited. And over here the load resistance is there, RL. This side V in, plus minus, current is flowing like this way, and this side is V output. Now we can see in positive half cycle current is flowing in this way, so current I is flowing. V output is equal to I into RL, and that is nothing but V in. In this one, this is a single loop circuit, so voltage across RL will be nothing but V in such case. So we'll get whatever input signal is there, we'll get for that positive half cycle, because of diode is in on condition, we'll get V output equal to V input. Let me draw the output signal over here. So this is vertical voltage X, and this is a time axis. V output signal, this is V output, and for our understanding I'm just for alignment, proper alignment, I'm drawing this lines. So let us see for positive half cycle what is happening. Positive half cycle, V output is nothing but V input, so we can draw like this way. V output is V input. So this is what our output is. Here from the name itself we can say that is a negative clipper. So negative part of this waveform will be clipped. Now we'll go for the second half cycle, that is a negative half cycle. So now in this negative half cycle we have to change the polarity. Now our input is negative half cycle. Now you see when the input is in negative half cycle, what will happen? This terminal become positive, this is negative. Current is flowing anti-clockwise. Now you see this terminal in this negative half cycle, the polarity differs. In this one, this n type got positive and this was negative. So Vp minus Vn is less than 0. The diode is in reverse bias. So that is what happening in our case. See, this is positive and this is negative now. So what will happen? Vp minus Vn will be less than 0. So this diode is not going to get turned on. So what will happen over here? In this case, the diode is switch off, or you can say reverse bias. So in our case now here, if I draw that output circuit, this is positive, this is negative, and current in anticlockwise. Actually diode is in reverse bias, or I can say this is open circuited. So current is not able to flow. That means I equal to 0. If I equal to 0, if I put I equal to 0, our V input will be like V output will be 0. So I can write this one directly. This will be 0. So in our case, if I see output waveform for this negative half cycle, I will get output equal to 0. So in this case, if I repeat the waveform, this will be like this way. Positive half cycle, it will be V input equal to V output, and negative half cycle, it will be 0. So this is how we get output waveform for sinusoidal input. It is a negative clipper, so negative portion of the waveform is totally clipped over here, and it is in series. Negative series means diode, this diode is in series with load resistance, so this is negative series clipper. I hope you understood this circuit. In upcoming video we are going to see negative shunt clippers. Thank you very much.